So basically your Zener diode, what is the basic difference in PN junction from the construction point of view? What is the basic difference between normal PN junction and your Zener diode? Who can say? Is there any difference? So in Zener diode, basically it is a very heavily doped PN junction diode. So doping concentration is more in, yes?
Nothing.
Nothing, there is nothing.
No, ma'am. Sorry, ma'am.
Okay, okay,
Nothing.
okay, okay, I got okay, okay, got it. Okay, so basically Zenodite is a very heavily doped, means doping concentration is more. So as the doping concentration is more in Zenodite, obviously the number of charge carrier is also, concentration of charge carrier is also more, and the depletion layer region is very thin in case of Zenodite. So this is the primary difference which is from due to which we got the difference in the characteristics of your Zener diode and normal PN junction diode. If you go for the characteristics of uh, Zener diode, it appears to be the same as your normal VI characteristics, but only the difference is that we can operate in the reverse bias mode. Whereas in normal PN junction diode, in the reverse bias mode, we get very small amount of current, and if you increase the voltage, then it will be enter into the breakdown region, and diode is not able, we will not able to operate the diode. Hello? Yes, it has already been started. You are from section C now. Section E. Section E lab is not. Yes, yes. Section E lab is not now. Na section E second half 130 to 220. In 130 to 420 lab period is there. Section E. Now section C lab is going on. Why you got confused? Okay, 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 okay. Okay, so in Zener diode characteristics, in or normal diode PN junction characteristics, if you see, then in the breakdown region we will not able to operate the diode. The diode will be damaged. It will not tolerate that much of reverse voltage. But in case of your not Zener diode, as the doping concentration is very high and the depletion region is very thin, so when we apply some external electric field, then due to that concept of your avalanche and general breakdown, two concepts are there. One is due to the application of very heavy electric field, and another is due to the if one free charge carrier is free electron is collide with other, it will break the covalent bond and it will create another pair of hole and electrons, then they will hit with other and they will create again further pairs are generated. So in an avalanche process, the number of charge carrier get multiplied, and at a instant when the minority charge carrier becomes very high, suddenly it will cross the junction and your current increases very heavily. So that is basically in your concept in your Zener diode. So the characteristics of your Zener diode is, it is just like normal PN junction characteristics, but only we have to observe the reverse bias characteristics, which is basically the reverse bias characteristics. So the reverse bias characteristics we need to analyze, and we have to find the breakdown voltage. At breakdown voltage means when the voltage remain constant and current will going on increasing, that will be the breakdown voltage. So in one part of the experiment we have to study the VI characteristics, and other part we have to apply the Zener diode for its as a voltage regulator. So as a voltage regulator, we need to uh, study the diode. Zener diode, you apply the study diode in Zener diode in a circuit, and you just study its behavior, how it is regulating the voltage, means with the variation of the load, also how the voltage remain constant at the load. That things we need to study. So this two part you have to do in the Zener diode experiment. So actually, what is not responding now? So how it is behaving like a voltage regulator, that circuit all of you know. One simply Zener diode is connected and one resistor along with this one resistor is connected. It is not responding.
Okay, ma'am. Can I share the screen from here?
Yeah, actually,
Yeah,
please
maybe
say it is not responding here.
Yes, yes.
Let me stop the sharing.
So is the screen visible to all of you?
Yes, sir, it is visible. Just little bit zoom kar दीजिए.
Okay.
Yeah, this is the voltage regulator circuit. So here you have to connect one Zener diode, and we have to make the reverse bias connection for this Zener diode. So that's why the N side is connected to the positive terminal of the supplied voltage. It is the DC voltage applied from 0 to 30 volt variation you have to do. And one resistance R1 is connected as the source resistance, and other are the load resistance. So different load resistors are connected. So when we make one resistor connected, other will be remain, they will be disconnected. So we have to check with each resistance. So once the so little bit scroll upward in the first observation table.
Okay. This one.
Is the circuit is given, sir?
No, it's only the table.
Okay,
The
circuit is
circuit
not given,
is
no?
not given.
Okay, so for this case, you have to connect the Zener diode in the reverse bias mode, and just you have to vary the input voltage. Okay, input voltage you want to vary, you need to vary. Then you measure the current through the circuit. What is the input current through the circuit? Then what is the current across the diode? That current you have to measure. So two emitter you have to connect, and one voltmeter that will be connected across the diode. So basically the VI characteristics what we need to draw, in that characteristics the voltage across the diode and current across the diode that we need to plot. So apply voltage VI that you need to vary the voltage from 0 volt to several, it may take up to 15-20 volt also. So if you just vary the voltage, accordingly the current will increase and the general current will also increase. And you can see that the VDC voltage across the diode will initially increase, and after a certain amount of your voltage, the voltage remains constant and current will going on increasing. So that voltage where the it started remaining constant, that will be your breakdown voltage. That will indicate your breakdown voltage. After that the voltage will not increase but the current will increase.
Okay, I think this one.
Yes,
Yeah,
no,
this one. This one
yeah,
maybe, no?
this characteristics, yeah.
Yes.
So if you can see that in the multisim, it will create, it will, the graph will be very accurate. In the multisim, it will be only fixed voltage. In the hardware, little bit fluctuation will be there, but in the multisim, you will get only the constant voltage and the current will increase very rapidly. So this graph you need to plot. Okay, and in the next part of this experiment, in this graph, this voltage regulation part you have to do. So regulation means your output voltage must be constant voltage. So whatever the load we will connect, if you connect a Zener diode in parallel to the load, then it will be regulated, the voltage will be regulated. So voltage drop across the load will be constant. So for different type of different value of your load resistance you have, if you want to connect, but the condition is that the applied voltage that should be above the Zener voltage. So here, like suppose D1 5 volt it is written. That means it indicates that the Zener voltage is 5 volt. That is the breakdown voltage of the Zener is 5 volt. So here you have to apply the voltage that should be more than 5 volt. Then only it will regulate. If you take less than 5 volt, then the Zener will operate not in the breakdown region. It will be operated before the breakdown region. In that case, you will not get the constant voltage because the current will very negligible amount of current will be there and the voltage will be again will be there. So you have to operate it after this beyond this voltage. So applied voltage should be more than 5 volt here. And after 5 volt, if you take 5 volt, 10 volt, 15 volt, like that, whatever the input voltage you are increasing, but the output voltage will be same 5 volt you will get. It will be in the shunt connection or the parallel connection. So the same 5 volt voltage will appear across the load. If you vary the load, if you even vary the load, then only your voltage will be constant. These things you need to check through the circuit. You just implement the circuit and take the variation, and you can observe this relationship. So for this one observation table you have to make, where you have to take the different resistance value and you output voltage you need to show. Sir, can you go to the next experiment?
Yes.
Yes, in the next experiment we are having the rectifier. So what is the aim of the experiment, sir? Yeah. Measurement of rectification efficiency and ripple factor of half wave and full wave rectifier circuit with and without C filter. So this person is already covered or it is going on in your class?
Ma'am, going on.
I'm not covered.
Going on,
I'm going on, not covered.
not
Not
completed.
covered yet.
Okay, so basically when we discuss about the rectifier, so rectifier means it is basically it will convert the AC signal into DC signal. That is the basic objective of the rectifier. Okay, so when you use the simple rectifier circuit, it may be half wave or full wave rectifier circuit, and simply if you apply the input voltage and observe the output voltage, then we are getting a pulsating DC, not the pure DC we are getting if you are using a rectifier only. Okay, so pulsating DC means it is a unidirectional current we are getting. Means if you are giving a sinusoidal input, then there will be positive half and negative half in the input, but in the output of the rectifier circuit only your positive half will appear. Okay, so in the half wave rectifier circuit you are having sir, please go downward whether these waveforms are there or not. Yeah, this one. So this is for the half wave rectifier. If you are applying the input source voltage like this, you are getting a pulsating DC waveform like this. Okay, for the negative half cycle, we are getting zero. Voltage will be zero, and for positive half cycle, we are getting the waveform. But it is still not a DC signal because it is having a time period of again the 2 pi time period. So obviously 2 pi time period is there, means frequency will also there, but DC should have frequency 0. So this is the case of your rectifier output. So that's why we need to connect one filter circuit which will filter out the AC component and it will allow the DC component. So there are various kind of filters are there. So capacitor filter or LC filter or CLC filter, different filters are there. So I think in your experiment only capacitor filter is used. So after using the capacitor filter means what is its significance? If you connect one capacitor across the load, so across the load, if you just connect one capacitor, then what will happen? Just like this. So this is the circuit. Here RL is the load resistance, and across this one capacitor is connected. So when we measure the load voltage or the output voltage, it will be before that one capacitor is there. So obviously when capacitor is there, so it is having a charging and discharging phenomenon. So we have to just when the capacitor will charge, means when the current will pass through this loop, when the current will move through this loop, that means when the current is through this diode and through this capacitor, when this loop current is conducting, at that period capacitor get charged. So in the positive half cycle, when the diode is forward biased, in this case your capacitor will charge, and charge up to which amount of it will get the charge, up to the maximum voltage of your applied voltage, up to that amount it will get charged. So that charging time constant, that is tau, is equal to RC. So capacitance into the resistance of that path. So resistance of that path means that is the forward resistance of this diode, which is a very smaller quantity. In comparison to your load resistance, the diode resistance is very small. So this time constant is very small, tau is equal to RC. So resistance of this diode into this capacitance value, that means that will take very small time to charge up to the maximum value. So the capacitor get charged with a very small amount of time to its peak value. Then what will happen? Then when the diode is comes to the when the peak voltage will reduced and it is the waveform is falling down, in this time the capacitor will start discharging. So it will discharge through which path? So in the next half cycle the diode is reverse biased, so this part will be open circuited. So we have capacitor is having a charge of maximum value, peak value of your voltage. This much of charge is already there in the capacitor. But when the diode get reverse biased, in this case your capacitor will discharge through this loop, through the RL. So this RC circuit, this will be a closed circuit. So the capacitor will discharge through the RL. So the and you know the load resistance is much more greater than your forward resistance of the diode. So the discharging time is very much, it is significantly more than your charging time constant. So it will suddenly charge, but it will discharge very slowly. So until when it will discharge up to the period when the capacitor is again, when the diode become again forward biased in the next half cycle, again the capacitor charge will again charge to the peak voltage. Means the capacitor will not discharge completely during this duration, because it is very slowly discharged, because the time constant is RC, that is the RL and C. So it will take a more time for discharging. So it is not completely discharged and again it gets charged. So with this phenomenon the output voltage will be in this shape. Now instead of this pulsating pulsating DC form, the output is just like this. And with the adjustment of this charging and discharging time constant, discharging time constant means with the application of the proper amount of capacitance and the load resistance, it can become more flatter. So it will be just very closely we're visualizing. When we see in the practical case, it is appear to be a just like a straight line. Little bit disturbance will be there, but it will be straight line. So we will have a pure DC signal with the capacitor. Okay, with the capacitor, we by using a filter, the it is exactly not 100% pure DC signal, but the AC content in comparison to this pulsating DC signal, the AC content of this signal is much more less. So we can say this is a DC signal also. So here actually there are certain parameters like ripple factor and efficiency. These are two very important parameter of your rectifier. So that two parameters need to be calculated here. So obviously efficiency means you know the efficiency means how much efficient your device is. For efficiency means any efficiency, that is the output by input ratio will give you the efficiency. So you can calculate the efficiency from the formula which is derived in your half wave rectifier circuit. Theoretically, actually efficiency is 0.482. So that is 48.2% of efficiency you will get theoretical value. So practically, what is the efficiency that you need to calculate? And likewise the ripple factor. Ripple factor, if you want to calculate, then how much AC content is there in your waveform, that is the ripple that indicates the ripple factor. So in the half wave rectifier circuit, more AC content is there, and in your rectified after
Sorry,
connecting, yes,
ma'am,
after connecting the
ma'am, your voice is lag.
voice
Ma'am,
is
your
less.
voice is lagging. I can't. Ma'am.
Yeah.
No, ma'am,
So
lagging.
okay,
Lagging.
okay. So
Actually,
I can't hear the repetition
it is
factor.
clear for me. So I don't know.
yes,
Means,
so you
Rishabh,
need the
please check the internet connection at your end. Maybe it may be the issue of your internet. I don't know. Means, what about others? Can you hear it properly?
Yes, sir. We can hear you.
Yes, sir.
Okay.
okay.
So
So
Rishabh,
efficiency you just calculate, and by first of all you need to calculate the IACRMS, IDC, IRMS. Can you say what is the difference between this IRMS and IACRMS? IACRMS will be required for calculating the ripple factor. So this is the RMS value for the AC content of the signal. Okay. So there is the formula where it is derived. Okay. So when we are having a pulsating DC waveform, okay, in that waveform also some DC part is also there and AC content is there. If you remember, if it is discussed in the theory class, any periodic waveform, if you just expand through the Fourier series, you can just observe that the first component is a DC component which is not having any sine or cosine term. It is a fixed quantity, and rest part will have some sine and cosine term. So excluding that DC part, whatever the rest AC part is there, that for that if you are calculating the RMS value, that is the IAC RMS. And this IRMS value we are calculating overall RMS value of that signal. Okay. So this RMS value and this IDC value, IRMS value, all these values you need to measure from your circuit. Then you simply by dividing the or by putting the formula whatever it is there, you can calculate the efficiency and ripple factor for both the half wave rectifier as well as full wave rectifier circuit. In the full wave rectifier, only the difference is that your waveform where the time period becomes pi, instead of 2 pi the time period become 2 in the becomes pi, because there we are getting for each half cycle we will get both for the for this one both for the positive half cycle also we are getting the output, and for the negative half cycle also we are getting the positive output. So this is the pulsating DC waveform in case of your full wave rectifier circuit. So previously the it was the time period was 2 pi. In the half wave rectifier, in the output also time period becomes 2 pi, but here that output period become pi. Here the time period is pi. And here we can applying the filter also. After connection of your filter, you can just check the ripple factor, and without applying the filter, you just check the ripple factor. So once you just make the circuit, without the capacitor you calculate the values, and with application of the capacitor then we calculate the value, and you can observe that the ripple factor value is much more improved by using the filter. So these two observation you have to take, and also the whatever the out waveform you are getting in your CRO of your multisim, that also you just keep and make the screenshot, and you just keep it in your lab file. Otherwise you can draw also if you are not able to take the screenshot, those who are using that lab system. I think the screen is very small, so if it is not properly visualized then you can draw it yourself. So this much you have to do. So start your experiment. If any doubt is there, then you can just ask.
I think, madam, we can show them these experiments in multisim. Maybe that may help them.
Um, I think
Raghavendra
this,
sir, if he is
I think sir they can do, because they are now
okay.
acquainted with multisim. And
Okay.
if they will not be able to do, then we will show.
Okay.
Let them do their self.
Ma'am, now my system is ready to connect.
Okay.
So I want to, ma'am, know
Yes, sir.
number of students who want to use the system.
Sir, I think we have already provided the code, na? That password for that.
Yes, ma'am, but some students had not joined last time. So
Okay,
one
okay.
by one, please student tell your name, then I will provide you ID. Sasank Raj, I think he had not used our system.
Sasank.
Excuse me,
उनका
sir.
जो लिस्ट था उसी को खाली डिक्टेट कर देते हैं, इसमें से और कोई यूज करना नहीं चाहता उसका नाम उसमें हटा देते हैं, जो यूज करना चाहता है उसको दे देते हैं.
Okay.
हाँ.
Sir, excuse me, sir.
Yes.
Sir, you can actually remove my name from the any disk.
Okay, you are now you have installed that, na?
Yes, yes, ma'am.
Okay. Yes, Tirki.
Yes, ma'am.
इसका शशांक का नाम हटा देना है यहाँ से.
No, sir, my name Yash Tirki.
Okay, okay.
You can remove my
तो
name
मैम
also.
बारी बारी से स्टूडेंट का नाम डिक्टेट कर देते तो वही सेव रहता.
So you can remove my name also.
What is your name?
सर वो वाला लिस्ट है क्या जो लास्ट टाइम आप लिखे थे, किन 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 को एनिडेक्स का जरूरत है?
List. Let me check. I think it should be there.
Other student, you just start your work. Okay, those who are having problem, then you can contact. Otherwise, you can just start your experiment.
Okay.
Ma'am,
So
one problem.
yeah.
Ma'am, sir, one problem is here. Sir, how can we get the Zener diode 5 volt?
Which one?
The Zener diode 5 volt.
5 volt.
Sir, in the experiment number 3.
Okay. So actually, you can find the detail in that lab manual. So have you checked that?
Sir,
That lab manual?
yes, sir, I checked, sir. I am asking that in the Zener diode,
Okay.
they are very much component like IN, I02D. So which we have to take?
I'll just let me. So you are talking about means from multi-sim, which Zener diode you have to pick? Is that like that? What is it?
Yes, sir. Yes, sir.
Okay, so can you please share your screen? Then maybe we'll be able to understand.
Yes, sir.
Yeah.
सर
Yes, Jessica.
सर आप मल्टी सिम में सिखा सकते हैं सर, प्लीज प्लीज सर.
Okay, let Rishabh open his screen. Then from there we can learn. Is that fine?
ओके सर, ओके.
Okay.
It is visible.
Yeah, it is
visible.
visible. It is visible. So that diode part, from where you are picking the diode? Yeah, the remaining part is okay, I guess. But you have to also add one one voltmeter, right? Across. Yeah.
So here the genre. Which genre we have to take?
Raghavendra sir, can you please suggest him which Zener diode he should pick?
Sir, actually, he may choose 12 volt breakdown Zener diode. So he
Okay.
may type 1Z12.
Okay, 1Z12. Yeah, Rishabh.
Yes.
Yeah, it came only 12. Yeah.
So the breakdown voltage of this Zener diode is 12 volt. So
12
he may choose the source voltage, and when he will increase the source voltage from after 12 volt, it will show breakdown region.
Okay.
So how we can take the variable voltage that I have taken only 30 volt. We have to take 0 to 30 volt now, variable.
Yeah. So in previous experiment, I think you have chosen variable DC source.
No, sir, variable, I don't remember.
Yeah, for
So
that PN
go to
junction,
source,
yeah, sir. Yeah.
go to
Is it
source,
here?
then signal voltage sources, and in signal voltage sources, choose DC interactive voltage.
Oh, this is that. Oh,
DC interactive voltage. Go to source, then click on signal voltage sources, then DC interactive voltage. Yeah, it is your variable DC source. And in this variable DC source, you can set the upper limit of voltage, lower limit voltage, and percentage increment.
and sir, one more problem.
Yes.
So in the experimental setup of experiment number 3, so in the uh, they is given some another thing in place of this and in place of this, U1 and U2. What is it?
In experiment, you may choose 1Z12 Zener diode.
Yes, yes, sir.
Yes.
So is it okay or anything is left here?
No, it is okay.
One voltmeter is left, I guess, at the end of the circuit.
So
Means,
where we
and
have to say in the
the
experimental
rightmost.
setup? So here,
Yeah, means in the, yes, exactly, in that part. If you see that
in the parallel,
lab manual,
parallel. Yes, sir.
Yes, sir. Its circuit is short circuited.
yes.
So can you explain how to get the variable potential? Again, I didn't listen at the time.
So Rishabh just did that, right? Please focus on this lab. Okay.
Sir, actually, I was doing multisim, so that's why I didn't see.
Okay. So Rishabh, can you please show him once again? From where did you pick that variable voltage source?
Yes, sir.
Yeah.
Signal voltage source, DC interactive voltage. Here. Is it okay, sir?
Yeah.
Thank you.
Sir,
Yes.
so please accept my AnyDesk request, sir.
Niloy, right?
Yes, sir.
So Raghavendra sir,
Nila Namit.
yes,
Yes.
Nilay.
Okay, just hold on. Your AnyDesk ID?
So 106529106.
Okay. Okay, now you are connected.
Thank you, sir.
Excuse me, sir.
Yes.
Sir, what's the button to press for increasing the voltage slightly, like by point, like what we have to press, which key in this signal voltage source?
So I think if you take your cursor to that source, then you will find that there will be one knob kind of thing.
Yeah.
So you can actually just
Okay.
drag that knob to the right or left.
Thank you.
Sir, one question, sir.
Yes.
So, where is the key in the experiment number 4? I am showing. Yes, sir.
Which one? Peak?
Sir, key.
Which one? Can you please repeat it again?
Sir, key. K-E-Y.
Key. Okay,
Yes, sir.
key.
Here.
Okay. Okay. So this part you have completed, right? This experiment 3 you have completed.
Yes, sir.
Okay.
So, and this is the experiment number 4, sir. Which is
Okay.
left.
Raghavendra sir, is there means any particular button where from where he can choose the key, or it's like just he has to keep it open and he has to do it manually?
No, sir, he may choose switch and the switch will come in basic group. Okay, all the passive components, the group in which you may get register transformer, in the same group you may get switch.
Okay, sir.
Mm.
Did you get it?
I am trying.
Yeah, that switch you can see.
In basic.
No,
in basic.
it was there. Means come out, come out. Yeah,
Yes.
that switch you can see the switch. Yes.
And there are various types of switch. So first of all, you have to choose which you have to decide which type of switch you want. Single input, single output, or single input, double output.
Yes, sir. Single in.
So in this case, which switch we are using, Rishabh?
Sir, single
In that
input.
manual? Okay. So I think now is it clear to all of you is how to do this experiment 3 and 4 in multisim?
So one more question, sir.
Yes.
So here in the experimental setup, there is one more line from this uh, wire from this, but we do not get the wire from in the middle of this in the experiment number 4.
Okay. So that. So you're asking that from where you can find that wire, or what is it?
No, sir. Wire not. So here there is a terminal like in the experiment number 4.
Yes.
Yes, sir. But sir, we do not get any component like this.
So actually, you have selected one primary, one secondary transformer. You have to select one primary and secondary tapped. That is the second option.
Sir, this? Oh, yes,
Yes.
sir.
Yes.
Yes.
Thank you, sir.
So it is clear, right? How to do
Yes, sir.
this experiment 3 and 4? Okay.
So in experiment 4, they asked for VRMS one, sir, the AC power source, not this source.
Oh,
Yeah, Rishabh. So you have to, but I think you have considered AC source, right? This is AC source.
yes, sir. I will delete.
Okay. So, madam, can students share their screen and show us the experiment 1 and 2 who could not show it on last day?
Yes, sir. I can also, sir.
Das madam?
Other students, you just start your experiments, and those
Yes.
who have not shown their results in the first two experiment, you just show.
Ma'am, I can show. Can I show, ma'am?
Yes, yes, you can.
Yes, yes.
So this is the experiment number 1A, MA. So is it visible?
Yes, visible, visible.
This is the experiment number 1A. And this is 1B.
Okay, so are you getting that Lysergis pattern?
Yes, ma'am. And then C. And then this is the C.
Okay. So can you show that? Can you run this experiment?
Yes, ma'am.
Okay.
And experiment 2, forward and reverse bias. And this is the forward bias.
Mm.
And this is the reverse bias.
Mm.
Ma'am, is it okay?
Yes, yes, okay.
And then I have also completed experiment number 3 and 4, ma'am. Then
3,
something
4
is
also you
left
have
here.
completed. Okay. So you can show.
And I have already shown this, sir.
Yes, Rishabh Rajna.
Yes, ma'am.
Okay, you have completed 3, 4 also.
Yes, ma'am.
Okay, so you can show.
Ma'am, in the experiment number 4, I have doubt, so I can't show it now.
So what's your doubt? You can clear now.
Ma'am, it's clear. I just have to connect the circuit and then I can show you.
Yeah, Rishabh, you can complete it, and in the meantime, let other people to share their screen.
Okay, sir. Okay, sir.
Okay.
I will stop presenting.
Yeah.
Sir, can I share?
Yes, yes.
Sir, is it visible?
Yes, it is visible.
This is the first one. This is second one. is the third one. This is the forward biased one.
So have you taken the readings for forward bias characteristics and got that graph properly?
Ma'am, this is the second one for forward biased.
Yes. So
Yes, ma'am.
have
Yes,
you
ma'am.
got the graph properly?
Yes, ma'am.
Okay.
Also in that third one, your that Lissajous plot, that was looking something different. Can you go to that third one again?
Yes, sir. One second. This one, sir.
No, it is fine. No, it's fine. It's fine. It's fine.
Okay, sir. And this is the reverse biased one. Is it fine, sir?
Yes.
Okay, thank you, ma'am.
Ma'am, I have done experiment number 3 and
Ma'am, may I say that?
Ma'am, can I see it?
Experiment number 1, 2 or 3, 4?
ma'am,
Ma'am,
experiment
1, 2 and 3.
I am on any desk, ma'am.
1, 2.
Who is doing from any desk?
Yes, ma'am, me Pratik.
Pratik. Okay, you just Pratik show.
I have to share my screen.
Yeah.
Okay. Is it visible?
Yeah.
Yeah. This is experiment number 3. Is it correct?
Experiment number 3. So
Yeah.
1, 2 already you have shown previous class.
Yeah.
Okay.
As I'm changing the voltage here is also changing.
So this Zener diode is having how much voltage? 12 volt. Okay.
Yeah, 12 volt.
Okay, so you can just check the voltage. Okay.
Okay. Yeah, 12 volt.
Yes. You are getting how much voltage at the output? 10.11 point something, no?
Yeah.
Next, you just increase 15 volt like that. 11.5. So it is constant at is 11.
Yeah.
Okay.
Around that level.
Okay.
Excuse me, ma'am.
Can you change the
Ma'am,
resistance?
there is one.
Yes,
Yeah.
Rishabh.
Yes, ma'am. There is one doubt in experiment number 4, ma'am. And what is it in the top right corner? And there is the oscilloscope and there is something. Can't understand what it is.
Okay. Just wait 1 minute. Let Pratik has to complete.
That's multimeter.
Okay, multimeter.
I've changed the resistance.
Yeah, just solve for the higher voltage so that the regulation can be shown. So take the voltage to 15 volt, 16 volt like that. Okay, now it is 22 volt. Okay, it's okay. Then experiment number 4, already that also you have done.
No, ma'am, I'll do it right now. I've not done it yet.
Okay.
Can I stop?
Yeah.
Thank you, ma'am.
Ma'am, can I show that?
Ma'am, can I see on the screen?
Who is saying that for screen sharing.
Can I share?
What's your name?
Can I share? Pranshu.
Pranshu, which experiment?
1 and 2.
1, 2, okay.
Is it visible?
Yes, visible.
This is the first experiment, AM. This is the second one. And this is the third one. This is the forward bias. And this one is the reverse bias one.
Okay.
And experiment 3 and 4, I am just doing it. I'll show.
Ma'am, can I go next?
Hello,
ma'am. Can I present next?
Yes.
Excuse me, ma'am.
Yes.
Ma'am, my values in the AnyDesk is not changing.
Which Abhishek?
Ma'am, Nila and Amit.
Nila and Amit.
In
Values are not changing.
Yes, ma'am. I'm using the AnyDesk.
Okay, so Raghvendra sir, please check. Raghvendra sir.
Yes, ma'am.
So Nila and Amit is saying that in he's using AnyDesk and the values are not changing in his system.
Excuse me, ma'am.
Okay, yes.
Ma'am, in the experiment number 4, how can we get the RL? Since ma'am, not register, RL is there in the experimental setup.
Experiment number 4. That means your rectifier. Rectifier?
Ma'am, for regulating the register, is that type of register?
Regulating the register.
Which experiment you are talking about? Janat diode or rectifier?
Sir, 4.
So it is rectifier, right?
Yes, sir, rectifier.
Okay, so what is your question?
No, sir, what is it?
Sir, in the PDF, it was written as RL, sir, the resistance. He's
Okay.
asking where can we find RL?
Okay, that resistance. Okay, that resistance you can pick it from that same section.
Sir, is it,
okay, from where?
Sir, is it register?
Yes.
Is it register or amplifier?
Amplifier. No, there is no amplifier, right? There is one resistance only.
No, sir, rectifier. Sir, I am saying is it register or rectifier?
Okay, so can you please tell us the page number of our lab manual? From which page number you are talking about these things? That will help us. What is the page number? 36. 36. Okay, so there is one resistance, that is RL equals to 1 kilo ohm. Is that okay?
Yes, sir.
Is that okay? What was your confusion regarding this?
Sir, I am saying that it is RL, so I can't understand it is register or some kind.
No, it is resistance. Actually, you can see that this symbol is for the resistance. Okay, and on the left hand side you can see that that is the symbol for the capacitor. Then is there are different symbols actually. Okay, so also so whenever you will see any that this kind of circuit diagram, so you have to understand what is that, whether it is resistance or capacitor. So this is the symbol that is actually used, okay, for the resistance.
सर
Thank you, sir.
Yes.
सर थर्ड एक्सपेरिमेंट में मैक्सिमम वैल्यू और इंक्रीमेंट कितना रखना है?
Which one?
थर्ड एक्सपेरिमेंट डीसी इंटरैक्टिव वोल्टेज.
For the third experiment, okay, so we are choosing that the Zener diode which has the breakdown voltage of 12 volt. Okay, so you can actually choose the voltage up to 30 volt. That should be sufficient, I guess. Okay, the 0 to 30 volt.
So can I share?
Ma'am, can we share?
Yes.
Sir,
One by one. Okay.
Yes.
One by
I'm
one.
Narayan and I'm sharing experiment 3 and 4, sir. I've already shown 1 and 2. So, so is the screen visible?
Yes, yes, it is visible.
So experiment 3, I've set it at 12, sir, and
Yeah. So
I've-
can you increase the voltage? Then
Yes, sir.
you can. Okay.
At 13, 14, it's staying almost at 11.
Yes, yes.
Yes, sir. And so this is experiment 4 setup. So what should we run in this, sir?
In that oscillator, we should be able to see that particular plot which Madam was explaining. So
There's no plot. So there's no display coming. 220.
सिमुलेशन एरर दिखा रहा है, क्या है ये सिमुलेशन एरर?
So okay, so I'll check this and I'll present later, sir.
okay.
Sir, can I
Sir,
present?
may I
Sir?
present now?
Sir, I have completed 1, 2, and 3.
What was your name?
So you
The last one?
complete the fourth also
Sir,
at a time.
Narayan.
Can show.
Nedumon
1, 2,
Lakshmi
3, 4.
Narayan Rao.
Okay.
Abhishek?
10073. Sir, I've already shown 1 and 2 as well, last class.
Okay. Yeah.
Thank you, sir.
Ma'am, I have done 1 and 2 experiment. Can I show now?
Yes, yes, you can.
Okay, ma'am.
And which Zener diode we have to use in experiment 4?
Is the screen visible?
Yeah, it is visible.
This is experiment 1, ma'am.
Okay.
Oh, sorry, I've switched to the wrong experiment. Sorry, ma'am.
Experiment
This is
1, third part you have shown.
Yes, ma'am. And this is the first experiment setup. When I am changing the volts per division and time per division scale, then the graph also accordingly changes.
Yes.
And for the second experiment, This is the Lysage's pattern.
It is not changing.
Your screen is not changing, Abhishek. We are seeing that same screen of that experiment 1.
So may I close and share it again?
Yes, now it is visible.
Is experiment 1 be visible?
Yes, yes.
So here is the Lysage's pattern.
Yes.
And when I change the frequency, we get a different pattern. And for the third 1C experiment, is it okay, ma'am?
Yeah. The screen is not changing. It is there in the Lysage's pattern only.
Yes, now it has come.
It is coming.
It is the setup for the 1C experiment. And for the second experiment,
हेलो
this
दीपी
is the
दास
one.
मैडम मैं कार्तिक बोल रहा हूँ
Yes.
हेलो
हाँ सर.
हाँ ये हम ये जानना चाहते हैं अभी 2 बच्चे जो सिस्टम एक्सेस कर रहे हैं
हाँ.
है कि नहीं
हाँ.
तो उसमें एक लड़का जो है शायद रेक्टिफायर का एक्सपेरिमेंट कर रहा है
हाँ.
हाँ तो वो कौन है उससे बात करना चाहते हैं अभी हम
Yes, ma'am. Yes, sir.
Pratik, I think you are doing na?
Yeah.
You are doing rectifier.
Yeah.
Okay, Pratik Krishna.
Yeah.
So I am in front of that computer which you are actually accessing from your side, right? So just go back to your circuitry first. Okay. So here you have taken one voltage source and its magnitude is 120 volt RMS, right? And frequency is 60 hertz.
Yeah.
Then you have selected one transformer, right? So this transformer detail, just click what is there. Hello.
Yeah, I'm doing
Details you check how much it is. It is a step down transformer. So you can see maximum secondary 1 voltage.
Yeah.
So maximum primary voltage is 500 and secondary voltage will be 250. So turn ratio is just half. Na?
Yeah.
So input we are giving, so 120 if you give, then around 120 root 2 we are giving. So in secondary side we will have 60 root 2. So it's very high voltage, no?
Yeah.
So,
Yeah, it is.
so can we change the transformer to say 120, say 10 is to 1 transformer? This is 2 is to 1 transformer.
Yeah. So we have to change it to 10:1.
10 is to 1. You just change that one to 10 is to 1 so that 12 volt we will get in the secondary side, because whatever DC supply we make, no, it's around 12 volt, 5 volt. That much we need to drive our electronic circuitry.
Okay.
Oh, here you can change. Here you put 120.
Okay.
Here you put 120. And here you get, say, around 12. Yes.
Okay. Is it right now?
Let's check whether it will do or not. No,
Okay.
it's not changing. So from where you have selected, you select the. Okay, anyway, go by this. We will go by this. Maybe it will work after we simulate, right? So
Okay.
now you take diode, one diode you take.
So which diode? I was
Any
not sure.
diode, any diode you, the switch diode.
This volt diode is okay.
No, that is linear. Just a virtual diode below virtual diode, one diode is there. One. So here you just come down and
Okay.
one and any diode you select, come downward. No, this is not. One and 4007. Normally we use that. 4007. Yes.
The first one, right?
No. You take third one.
Okay.
100. Okay. Connect. Put over here. Okay, place it. Not a problem. Then you go for one resistor.
Okay.
Resistor basic. Yes. Take 1 kilo ohm. One kilo. Okay. Now connect it. Go back to circuitry. Now do the connection. One ground you need to select, no? So you come to basic. Sources. Ground. Yes. Okay, so can you rotate this R1 clockwise?
Yeah.
Okay, so now do the connection.
Okay, wait.
Excuse me, sir.
Yes.
Sir, mine system is showing offline. Sir?
Okay. Two of you are using our system, no? From here?
Yes.
What's your name?
Nilanamit, sir.
Okay. So from here, probably. Okay, anyway, इसका नाम क्या था भूल गए? Okay, you do the connection. Pratik, you do the connection. For you,
I'm doing the
Can I
connection.
solve हो रहा है भाई? We are trying to give you the access once again. Not a problem.
Sir, can I share the scheme from for experiment number 3 and experiment number 4?
In fact, right now, just whatever Pratik is doing is visible to everyone.
Oh, sir.
No. Okay, so Pratik, you share your things now, so that everyone will be.
Is it visible?
Now it is visible. So now you take a CRO. CRO, third one. Fourth one, sorry. No. This is CRO.
Where is CRO?
No. From top, you just go. This is multimeter next. Function generator next. It is wattmeter next. Oscilloscope. Yes, this you
Yeah.
have to place it. Now
Right.
connect channel A. This one. Connect here. And minus of channel A, you connect to ground. Okay, good. Now you, okay, channel B, you can connect to primary.
Like. So here, over here.
No, it's just before the diode you connect so that you can see 12 volt. Before the diode. This side, sorry.
Okay.
Sir, I have already completed it. Can I say?
No. I'll just let him do first. Okay, now
Okay, sir.
ground you connect over here.
Negative side to ground.
Uh-huh. Okay, now simulate. Let us check. Click on CRO. Okay, volts per division you need to reduce. Volts per division. Channel A. Uh-huh. You increase that one to no. बढ़ाइए 5 10 20. Okay, leave it. Now go to channel B. There also you make 50. So in fact, whatever change we did, no, it's not taking.
Yeah.
Uh-huh. So that is there. Now what you do, you just below channel B, you see AC 0 and DC. So you put press 0 so that only channel A will be there. So it is rectified waveform.
Yeah.
We are getting.
Yeah.
Now what you do, you stop the simulation now and click on the source. 120 volt RMS. Either. This is 120 volt, no?
Yeah.
It's not taking. Even though secondary, how much it is?
120 60.
Can we change this one to 60 kilohertz? Now from here, 60 kilohertz you make. Oh, this voltage source you can change, no? 60 kilohertz you make, and this one around say 60,000 hertz. Okay, and go back over there. You make there 12 volt only. Now 24 volt. 24 volt. So now output will be 12 volt only, right? Now you do the simulation once again. Now expand time per division. Here time, yes. Further. Expand. Sorry, you time per division you have to decrease. Expand means no. 50. You make it microsecond.
Okay.
Okay, a little bit reduce it so that you can see. Volts per division is just increase little bit. No, increase. Sorry, expand along y-axis. Sorry.
Okay.
Or. Leave it. So this is now 60,000 hertz we have made. So it's not changing. Can you increase further your frequency?
Stop.
Another 0. 60,000. Okay. Now just simulate. Now increase. Expand. So something now problem is coming, no?
Yeah.
It's not properly rectified waveform. Hello?
Yeah.
So why this problem is coming? Earlier we were seeing that it is that rectifier was rectifying properly, but now it's if you further increase just then stop the simulation and increase the frequency.
Okay. Do I have to add one more zero?
Edit. It's simulation, no problem, no? Okay. Now, amplify. Volts per division. Volts per division. ओए ये क्या हो गया जी? हाँ?
क्या हो गया?
साइनसॉइडल ही आ रहा है ना, जैसा इनपुट था करीब करीब वैसा ही।
हाँ
हैं?
हाँ, वैसा ही आ रहा है।
तो ये डायोड तो हमारा काम करना बंद कर दिया।
Why, sir?
तो हमारा अगर जो हमारा लेबोरेटरी में जो डायोड है ना, अगर हार्डवेयर लैब में रहते तो इतना फ्रीक्वेंसी बढ़ाने की जरूरत भी नहीं पड़ती। लेकिन जो रेक्टिफायर, नॉर्मल रेक्टिफायर डायोड है, वो 1000 हर्ट्ज के ऊपर में गड़बड़ी दिखाना चालू करता है। यहाँ तो बहुत ज्यादा बढ़ती है हम लोग। तो वो अगर देखेंगे तो यहाँ पे अगर जो लेबोरेटरी में जो डायोड जो यूज होता है रेक्टिफिकेशन के लिए, जो पावर सप्लाई में जो डायोड यूज होता है, वो आपको 1000 हर्ट्ज के ऊपर जाएगा तो प्रॉब्लम करना चालू कर देगा, जो प्रैक्टिकल डायोड होते हैं। यहाँ सिमुलेशन है कि नहीं? इट्स मैथमेटिक्स ओनली which computes all the things. So why it is coming sinusoidal, why diode is not working now, right? That you have to think, right? Anyway, in fact, today just I was just interested in seeing this, how you people are doing, means accessing the system from remote location and doing the experiments. And of course, we are talking also online, and not so much lag is there. Whatever I am saying from your side, if you are doing some changes, right, it's a very fast. And even I'm seeing here, not only on this screen, in fact, on mobile phone also, right? In fact, it's quite clear. If someone, other students are also watching this, right? It's very fast.
Sir, I have doubt. Sir, I have doubt.
Yes.
Sir, can I share the screen first?
Yes, you do. Anyway, this is what I was interested in, just showing you that if any electronic device is there, right, it has got some limitation. And why this limitation is coming? It's because of that PN junction, right, which is forward bias or reverse bias due to the applied voltage, right? And when we apply when we make the PN junction forward bias, depletion region decreases, no? And we apply the reverse bias, and depletion region increases, right? And we see diode as a capacitor that point, because depletion region is not having any charge, right? You can treat this one as insulator, not having any charge carrier, so it will be as insulator. And charge carriers separated by that depletion region can be taken as, right, a parallel plate capacitor having dielectric, and one side we have electrons that as charge carriers, and other side we have holes, right? So it's going to act as a capacitor. Now at very high frequency, this capacitor reactance is going to be effective, and its reactance will be very low. So it will conduct in reverse direction also. This is what we are observing. Hello, is this point is clear?
Sir.
Now,
yes, sir.
Another student was
yes,
interested in.
Sir, I am presenting the screen.
Okay. So
is it okay? You see.
Okay, okay. So now I'll just changing this system. So now I can see your circuit also.
Yes, sir. So I am also showing the experiment number 3.
Whatever it is, you just show, not a problem. So it is visible, it is rectifier circuit. So tell me what is your doubt?
Is it visible?
Yes, this is linear diode, no?
Yes, sir. Sir, my doubt is that in the experiment number 4,
Okay.
sir, I am not getting that kind of you are illustrating that student.
What you are saying? No, in fact, probably here that CRO you have connected, no?
Yes, sir.
Waveform you are not getting, na?
Yes, sir.
So this channel A terminal, you disconnect first.
So
Channel
this,
A, CRO.
yes, sir. This,
No, positive one you disconnect. Positive one. Positive,
this now.
yes. Delete it. Delete. Okay.
Yes, sir.
Now you connect this one to positive terminal of the multimeter. Positive terminal of the multimeter. Okay.
This way.
Now another thing, in fact, this negative terminal of the multimeter you have to disconnect.
So, but there is a doubt, sir. That's
Disconnect
in the
it.
yes, sir.
Disconnect it.
Sir, yes, sir. But I have doubt, sir, that in the experimental setup, it is like that.
No, you just whatever correction is needed that I am doing.
Actually, you have connected multimeter in series. Okay. Hello.
Disconnect that.
No,
Yes,
you may use multimeter in series, but the range of multimeter should be in ammeter range, okay? Because in voltmeter range, the internal resistance of the meter will be very high, okay? So change the ammeter in ammeter range. Double click on multimeter and change in ammeter range. Then you will get.
In fact, here.
Yes, sir.
Right now. Okay, now it will work.
Now it will, the waveform will be shown on your oscilloscope.
Okay, earlier, that was the problem.
Yes, sir. Do earlier connection, you will get waveform.
Now it's coming, not a problem. But even though now, if you put that positive terminal of the CRO, right, A at the negative of this, then also it will work. In fact, earlier I was thinking that this multimeter is being used for measurement of voltage, but someone may use this one for measurement of current also, right? So ammeter will come in series. That is the problem. But now it's okay, right?
Excuse me, sir.
Yes.
Sir, my NADS system not of online, sir.
What's your name?
Sir, Nilayar Nahmed.
वो एक्सेस नहीं किया. Hello, any doubt is there now?
सर बार वो ऑफलाइन हो जाता है सर.
अच्छा, वो शायद कनेक्टिविटी का प्रॉब्लम हो तुम्हारे साइड से.
Sir, sir, I have shown both experiment number 3 and 4. So write my name, please.
Sir. Hello, sir.
Yes.
Sir, I want to share my screen.
Sir, I have done all the.
Yeah, Rishabh. Yeah, Rishabh. We have copied.
At a time,
okay.
one student should be
Hello.
Teacher.
Yes, Kundan. You want to
Sir,
share
I
your
want to
screen?
share my screen. Can I, sir?
Yeah. Yes. Go on.
नीलांजल.
Yes, sir.
हाँ ना, ये हम देख रहे थे कि ऑनलाइन कैसे शेयर होता है पहली बार.
हाँ सर, ये स्टूडेंट और लास्ट क्लास से स्टार्ट किया है।
है ना, ये तो बहुत अच्छा लग रहा है हमको। एटलीस्ट बच्चों से मतलब बात हो रही है सीधी सीधी।
हाँ सर।
नॉर्मल ऑन टीम भी।
हाँ सर।
ज्यादातर बच्चे मतलब
Sir, this is my experiment number 1, A part.
हाँ।
I am playing it.
Kundan Kumar, na? Experiment 1 2 you are showing.
Yes, ma'am.
Okay.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, my work is completed.
Who? What's your name?
I'm Rishabh Raj, 1008.
Rishabh Raj. 3 4 already you have shown, na? 1 2 earlier you have shown, I think.
Yes, ma'am.
Okay, so your one is completed. You just take the readings and make your observation table.
Ma'am.
Okay, ma'am. Is anything left for me?
You have taken the observation table?
Yes, ma'am, but not written yet, ma'am.
Yeah. You have calculated your ripple factor and efficiency?
Not, ma'am, not yet, ma'am. I have working on it to write in the lab copy.
Yeah.
Yes,
Hello, ma'am.
Yes.
Ma'am, this is experiment number 1, part 2.
Okay, Kundan. Okay. Experiment. Okay.
Ma'am, can I now show experiment number part 3?
Yes.
Ma'am, this is part 3 which I am running now.
Still part 3 is not visible to me. Yeah, now it is visible. Now it is visible.
Yes, ma'am, this is part 3, experiment number 1, part 3.
Yes.
Ma'am, I have shown 1 2 3 part in experiment number 1. Ma'am, now I'm showing experiment number 2.
2, yes.
This is experiment number 2, first part, and now I'm running it.
Wait. It is, yeah, now it is coming. Experiment number 2, forward bias characteristics. Yeah.
Yes, ma'am. It is running. Ma'am, now can I show experiment number 2, part 2, reverse bias?
Yes.
And this is reverse bias. And now running it. Now can I show experiment number 3?
Okay.
This is experiment number 3, and now I'm running it. And Zener breakdown voltage is 12 volt, and it is now working. If I will reduce it less than 12, then it shows like this reading. Ma'am, is it correct?
Yes. Increase the voltage.
Yes, ma'am, I'm changing the voltage. Now this is 12 volt. Ma'am, now I'm changing it to 13.
Yeah. So how much output voltage you are getting? Okay, 11 point, I think so.
783.
783, okay.
Yes, ma'am.
Okay, almost 12, okay.
Now can I stop and show experiment number 4?
Yes.
And this is experiment number 4, but I have done, but I don't know it is working or not. Please guide me, and I'm running it. And how now what I will do, I don't know, ma'am. I made this setup one.
Okay. So first of all, you have to do the half-wave rectifier, na?
Yes, ma'am.
Yes, for the half-wave rectifier, you have to take the key A open so that D2 will be disconnected. Only D1 will work.
Now I will
now you have
yes, ma'am.
kept
Key
the
2 I
D2
will
also open so that without filter you can take the observation.
Yes, ma'am. Now what I will do, I have started it, then I will show the properties of oscilloscope. Yeah, what?
Yeah, you can visualize the signal in the oscilloscope.
I'm doing it. Properties. It is showing like this.
Just double click on that. Yeah. So you have to little bit adjust its scale.
Yes, ma'am. I will do that. 10 volt. Time based channel. बड़ा हो गया. Now.
Yeah, it is now coming. Yes. So
This
it is
is
the waveform for the half wave rectifier circuit. If you want to visualize the input waveform also, then you can connect the input voltage source to this channel B of your oscilloscope, so that both the input and output waveform you can observe simultaneously.
What you told, channel B of
Yes.
channel B of oscilloscope, where I will connect it.
Like if you want to visualize both the input waveform as well as output waveform,
Yes,
just
ma'am.
like your theory, just we have shown in the manual.
Yes,
So
ma'am.
for you can you have to display two graph, so input and output. So for input you want to connect this channel B with your input source. Just close this out result, this part.
Yes, ma'am. Input
So
V2.
yeah, input where we are giving the input signal. So you can visualize the after this in here in this two terminal you can connect before D1 and this lower one.
Here.
Yeah, this one. In between this we are giving the inputs. This one you can give. Before D1 you can connect to channel B.
Yes, ma'am. And negative terminal of channel B, where I will connect it.
That you can connect to ground. With respect to ground it will show.
Yes, ma'am. I'm doing it. Now I will operate it.
Yes.
Saying properties. It is again channel B. It is now saying like this.
Yes, it is showing. So you scale the change channel B scale and just make the Y position change so that
Yes, ma'am.
one will be above other.
The bigger is for channel A and smaller is for channel B. Now this is half wave rectifier, ma'am.
Yes, half wave rectifier. Yes.
For full wave rectifier, what I have to do?
You have to close the switch like your this key one close so that both the diode will be now in the operating mode.
Yes, ma'am. Now I'm doing it.
Yes.
Can I run it?
Yeah, do it.
Yes, ma'am. Now it is showing like this.
Yes, it is correct.
Correct, ma'am.
Yes, if you want to show it a little bit, just distinguish this this output and input, just change the Y position जो है ना, Y position को थोड़ा सा change कर दो, तो separate दोनों signal तुमको दिखेगा.
Y position.
यहाँ पे है ना Y position.
ये.
यहाँ पे Y position 0 में है दोनों.
ये.
हाँ Y position, that one. Yeah.
I'm writing it 1.
Little bit increase you can.
Yes, ma'am. 10.
Yeah. Now it is visible. So this one sinusoidal is the input, and other one is your output. So keep the keep above input in the top, and below that you just kept the output. Just reverse.
Yes, ma'am. And when I will connect this capacitor for rectifying.
Yes, for filtering.
Yeah.
This observation you have got for without filter, the waveform without filter. Then when you make the switch A close, then with filter, the output waveform will appear.
Yes, ma'am, I'm doing it. Now I will stop working at this.
Yes.
May I share the screen now?
I will connect key 2.
Yeah, key 2, yeah. Close the key 2.
Now I will again play it.
Yes.
Now,
make it close. Yes, now you play, run it.
Yes, ma'am. Now I'm showing again oscilloscope property like this now.
Yes.
It is correct.
So that
Excuse me, ma'am.
Just wait 1 minute. Let him complete.
Is it correct now when I have connected the capacitor to?
Yes.
Yes, ma'am.
Now pure DC is coming. Okay.
Yes, ma'am. This
So
one straight
if
line.
you if you just change the scale so that it will be clearly visible if any ripple is there, that could be calculated.
Ma'am, which scale now will change it? Channel H or channel B?
Where you have taken the output, channel A you have taken the output. Now this is the input. In the channel B you have taken the input.
Yes, ma'am. Channel A is there is output.
Yes.
Capacitor is connected to channel A only.
Yes, yes.
Yes, ma'am. Stopping it right now.
And there is one doubt.
Ma'am, may I share?
Is it complete or anything more I have to do right now?
No. Observation you have shown, just you take your readings and calculate the efficiency, ripple factor, all these things. Okay.
Yes, ma'am. Now it's complete, ma'am.
Yeah, complete.
1 to 4 I have shown. From
Yes.
experiment
3,
1
4
to
you.
experiment 4.
3, 4 also you have shown. Your turn is complete.
1 to 4 I have shown. Thank you, ma'am.
Okay.
Now,
Next.
Ma'am, may I share?
Can I stop my
Yeah.
sharing?
Stop sharing.
Thank you, ma'am.
Ma'am, can I share now?
Ma'am, may I share?
What's your name? Om Kumar.
Ma'am, can I share?
Yes, ma'am. Ma'am,
Kaustup.
Yeah.
excuse me, ma'am.
Yes.
Ma'am, can you see?
Ma'am, my internet is not working properly. I might have to disconnect, so can I share now?
Okay, just after Kaustup, you just share. What's your name?
I'm Yatin Kapoor.
Yatin. Okay.
Ma'am, yeah.
Ma'am, I have also taken the reading.
Yes.
I have also taken the reading.
Kundan Kumar.
No, ma'am.
Okay, so you have Rishabh Raj. So those who have taken the readings, you calculate the ripple factor and efficiency, all these things you can calculate.
Yes, ma'am. I have calculated.
Okay. So Yatin, you just explain, show the results. So earlier you have not shown the
Okay, ma'am.
experiment 1 to Yatin?
No, ma'am. I'm showing it right now, ma'am.
Okay.
Ma'am, you can see a screen, right?
Yes.
Yeah, so this is part 1 of experiment 1.
Mm.
Shall I start it?
Yes.
Okay. So this is the sine
Now
wave.
your screen is not visible. It was earlier visible.
Okay, ma'am, 1 second. You can see now?
Yes.
Okay, so I'm doing this one now.
Yeah.
Ma'am, can you?
It's
Okay.
fine. So next experiment number, next observation.
B. Okay.
Hmm.
The
Yes,
pattern is
I
visible.
got
Okay.
it. Yeah.
This is the third part.
Hmm.
Ma'am, is it visible?
Hmm.
Okay, I'll go to forward bias one.
Okay.
Ma'am, so this is the forward bias one.
Hmm.
Start it.
Yes.
Okay. Ma'am, this is the reverse bias.
Okay.
Here's the breakdown part. Ma'am, it's fine.
Yes.
Okay. Okay, ma'am. Yeah, that's it. 3 and 4 have just done the setup till now.
Okay. Just complete 3 and 4.
Okay.
Yatin, next. Yatin.
Ma'am,
Yes, ma'am.
this is
Ma'am,
Kaustup.
yes, I'm sharing.
Yeah.
Yes, ma'am. Is it visible?
Yes, visible.
Yes, ma'am. This is experiment number 1.
Hmm.
This is the setup.
Yes.
This is experiment number 2.
Hmm.
Lysage's pattern.
So have you taken various Lysage's pattern?
Yes, ma'am. I've
Okay.
taken various. Do I have to show?
No, not at all.
Experiment number 3, 1C. This is the setup.
Hmm.
This is experiment number 2, forward bias.
Hmm.
And this is the reverse bias.
Okay.
This is experiment number 3.
Hmm.
I'm on increasing the voltage.
Hmm.
Is it visible? Is it okay?
Yes, yes.
This is experiment number 4.
Yes.
This is.
Yes. Okay, so you can stop sharing and calculate ripple factor efficiency of this.
Okay.
May I share?
May I share?
May I share?
What's your name?
Ma'am, can I share?
Harshraj.
Oh, ma'am.
Rishabh Raj. Rishabh Raj, Rishabh Raj, you have already shown, na?
Yes, ma'am. Yes, ma'am.
Your experiment number, I think 3, 4 also you have completed, Rishabh?
Yes, ma'am.
Okay. Next.
Can I share?
Someone has
Excuse
already
me, ma'am.
shared. Deep
Ma'am, I am
Jyot.
sharing, I guess. Yes, ma'am.
Okay, just quickly.
Excuse me, ma'am.
Yes, yes.
Ma'am, I'm Abhishek Singh, ma'am. I have just presented experiment 1, but when I was presenting experiment 2, then suddenly it stopped. Can I continue that?
Okay, let Dipjot has to complete, then you can.
This is experiment
Okay,
1A. Pattern.
Hello.
Okay, quickly, Dipjot.
Yes, ma'am. This is experiment 1B.
Hmm.
This is experiment 1C.
Yes. Yes.
Okay. This is the forward biasing.
Hmm.
This is the reverse biasing.
Hmm.
And this is the experiment 3. I'm changing the values.
Okay.
15 and the output is close to 12.
Hmm.
Ma'am, I haven't completed 4 yet. I'll just do it. Just show it to
Okay.
you.
Okay, okay.
Ma'am, can I show
Ma'am, now
next?
can I share?
Can I share?
Can I share, ma'am?
Can I share? Ma'am, can I share?
Who?
Ma'am, Devrishi.
किसका इनकम्प्लीट था? अभी
Ma'am,
अभिषेक.
मेरा अभिषेक कुमार
अभिषेक,
सिंह.
हाँ, कंप्लीट कर लो.
Can I
Yes,
share?
ma'am.
Just wait.
Ma'am, I have already shared experiment 1. So yes, ma'am.
1, 2 you
I
have
have,
shared. Okay, so 3, 4 you want to show.
ma'am, I have only shared 1. I want to share 2 now.
Okay.
Is it visible, ma'am?
No. Yeah, now it is visible.
And this is experiment number 2.
Hmm.
The forward biasing,
Hmm.
and this is the reverse biasing.
Yes.
Ma'am, I'm working on the experiment 3 and 4, ma'am.
Okay.
Ma'am, can I show next?
Ma'am,
May I share?
Devrishi.
Can I share?
Devrishi,
Can I
Devrishi,
share?
you just share.
Yes, ma'am.
Yeah, Om Kumar. What is it? Devrisi.
Ma'am, is it visible?
Yes, yes, visible.
And this is the first one. Okay.
Hmm.
This is the 1B.
Yes.
This is the 1C.
Yes.
And I have shown the biasing one. Should I show it again?
You have shown it,
Yes,
Devrishi.
ma'am. Yes, ma'am.
Okay.
And the
Both
third one,
3 and 4 you have shown.
no, ma'am. I have shown the second one.
Okay, okay. Second one, there is no issue. Okay. So
And
3,
this is,
4. What about 3, 4?
ma'am, this is the third one.
Yes.
Uh,
Just vary the voltage up to 15 volt. But here, okay, 11.8. Okay.
Wait,
So
is correct.
yeah, you have to take the readings for all this, and you have to plot the graph. Then you have to show that it is fixed at 11.881. Okay.
Okay, ma'am. And
Okay.
experiment 4 I have to show.
Yeah.
And this is the experiment 4.
Yes.
Ma'am, is it correct?
Yeah, it is correct. So when you take the screenshot, just make the scale proper so that properly it will be visible. Both the
Okay, ma'am.
input and output, it will be visible. Connect the input also in one channel of your CRO and output in other channel of the CRO. So and maintain the proper scale so that it will be properly visible.
Okay, now I have to show that.
Yes.
Ma'am, now I will show the second channel also.
Now you can do it. Okay.
Should I stop sharing?
Hello, हाँ ma'am. Good morning, ma'am.
Yes, yes. Stop it.
हाँ
Sir, can I show?
मैं आ जाती
Yes,
हूँ
go on.
Sir, can I share?
फॉर्मेट बनाना है
Can I
One by
share?
one.
One by
One.
one.
Prajwal.
ठीक
Hello,
ठीक है
sir.
ma'am. हाँ हाँ
Yes, Rishabh.
Actually,
So can I
sir, I
share?
wanted to.
Sir, can I share?
So
Yes. Who is sharing now?
Sir, sir, I wanted to say something. One concern.
Sir.
Chandrasekhar,
Hello,
right?
sir.
Yes, sir.
Chandrasekhar. Yes,
This is
Chandrasekhar.
experiment
Go on.
Sir, I
1A.
wanted to say something.
Yes, Rishabh. Say.
Yes.
Sir, that's sir, there are two Rishabh Raj in the class. So, sir, my roll number is 10087. So, write it.
I think experiment 1, 2 you have shown na Rishabh Raj 10087.
Sir, I have, ma'am, I have shown all the experiments, 3, 4 also.
Yeah, we have
Sorry, I
noted
have.
it.
Yeah,
What
you
is
have
the
noted it.
problem, Rishabh? We have noted it.
No, sir,
What is the
I
problem?
wanted to just say, sir, that my roll number is 10087. There are two Rishabh Raj in the class. So, sir,
Okay,
that.
okay.
Sir, am I
My roll
visible?
number is 87. 87.
Okay. Don't worry.
Hello, sir.
Hello.
Yes.
This
Can
is
I-
experiment
So
1
now can I
AMA.
share?
Chandrasekhar is sharing his screen. So let
this
him
is
finish first.
experiment 1
Okay.
AMA. This is experiment 1 AMB. AMC experiment 1.
Sir, I have problem in
This is experiment 2 reverse
transformer.
bias. And this is experiment 3. And this is experiment 4. Wait, this.
So in
This is
experiment 3, that voltage is changing or it is not changing?
Changing.
It is changing, right? Okay.
Yes.
Okay.
This is experiment 4.
Okay.
Okay.
Can I share?
Okay. So in experiment 4, as madam said, that you can
So can I share?
also show that your input voltage also. Okay. Just connect the terminal B with that source. Okay, and then you can show that both input and output in a same window.
Okay.
Okay.
Sir, can I
Sir,
share?
sir, I have
Can I
problem,
share?
sir.
So can I share?
I am sharing now.
Hello, sir.
So,
Hello, sir.
So I am sharing
Yes,
now.
yes,
so
tell me.
can I
So can I share?
Sir,
Sir,
where we
can I
where
speak?
we find the transformer?
Sir, can I
Sorry?
speak?
Where?
Transformer, sir.
Transformer, I think we already discussed that, right? In the beginning of this class, we already discussed that. So, yeah. Okay, so,
I'm not getting, sir, where
okay,
different option is showing in my
okay,
system,
so,
the multi-sim.
okay, we can do one thing. Let your friend Kunal share his screen, and from his experiment, you can see it. Okay? Is that fine?
Okay, sir.
So, Kunal, right? Yes. Yes, your screen is visible. So, Kunal, you just muted yourself. Unmute. Yeah.
It is the first experiment.
Okay.
Yes.
And the first experiment B, the Lechasius pattern that we have to solve. This
Yes.
Third experiment, ellipse. It is visible.
Yes, yes.
And this one, forward bias and reverse biased. Forward bias that we have to do.
So Kunal, you completed?
3, 4 you have done, Kunal?
Yes, yes, sir. Yes, ma'am.
We actually cannot see your screen.
3, 4 you have not shown.
Sir,
Wait, wait.
Kunal, so Lux
Yes, I have
is
sir,
now
actually
sharing the screen.
confusion हो रहा है sir.
Yeah, Risika, just wait for
हाँ,
some
sorry,
time.
sorry.
Okay, just wait for some time.
Experiment 1.
Yeah, Kunal, you did not complete that part. Yes.
Visible, sir.
Yes, it is visible.
Which experiment?
3, 4.
3, 4. This one is three experiment. Third experiment.
No, yeah, now it is visible. Oh, yeah, now it is visible. And fourth one?
This one is fourth.
Yeah. So Kunal, in this experiment, can you please explain to your friend that from where you found that transformer?
This transformer.
Yes, that transformer, from where did you find?
Yeah, let's go for this place source and first click all groups. Then you can manually write here transformer. Transformer.
Hello, sir.
You can click here and you can use it.
Okay, very good. So
Please show
someone
the
was
working. It's
someone was
working or
asking.
not.
Yes, Gautam, you are asking, right, regarding this?
Yes, sir.
Okay,
Please
so
run this.
so this one, yeah. Kunal, can you show us the output from the oscilloscope?
This one. Wait for a minute, sir. Sir, one experiment is running. That's why my other experiment is unable to run.
Okay, so you can stop that other experiment. Then you can show us. Yes. Now run it and show us the output.
Sir, in last experiment, I have also doubt how I don't get a correct clear result.
Just the same problem, sir.
Okay.
Sir, I have the same problem.
Yes, sir, same problem.
Someone
what's
actually
the
just
problem?
yes.
Sir,
So
what they're saying?
In the last
Kunal,
experiment, the
Sir, I
output is
think
not showing that accurate way.
So the positive terminal of the oscilloscope is connected to the negative terminal of the multimeter instead of the positive.
yeah, Kunal,
Yes, sir.
close this. So you have added the positive terminal of the oscilloscope with the multimeter negative terminal, or what is it?
The multimeter.
Okay, just let us check.
sir, I think sir, in the multimeter he has not set the ammeter. That I also
Yes,
made
sir.
It may be there. It may happen.
So in multimeter, which function you have chosen in that XMM1?
What, sir?
Just double click on your multimeter XMM1.
XMM1
Yeah.
I have used.
Yes, sir. Yes,
So
sir.
here
And
you have,
Select it as the ammeter. Select it on that A.
it is in the voltage mode.
Yeah. Now you run it. No, you have to run it, right? You have to.
This signal.
Just change the time base scale.
That 10 millisecond per division, you can
Change it.
change it.
You just increase or decrease. You can observe yourself what is required.
Yeah, reduce it. Reduce it. Yeah,
Also
now,
the
now you can
voltage.
see.
Also the voltage scale you can change.
Yeah, that voltage scale you can change.
Yes, sir. Now my also working, sir.
Yes, yes.
Is it clear now? Good.
Yes, sir.
Good.
So can I share?
So can I share?
So Kunal, right?
Can I share?
Kunal.
Can I
So,
share?
Can I share?
so can I share?
So can I share?
Okay, Om Kumar. Om Kumar
Yes,
is
sir.
sharing now.
Yes,
Yes,
Kunal
yes,
Kumar, na? Yes.
we have noted. We have noted Kunal. Okay.
Ma'am, after this, can I present?
Rishika, okay. After Om, you just present.
Okay, ma'am. Thank
Yes,
you.
ma'am. This is experiment 1A. This is experiment 1B, that is Lysage's pattern.
Hello. Yes, Renuka. Good morning. Good morning.
This is experiment 1C.
Okay.
This is forward biased experiment 2.
Mm-hmm.
This is reverse biased.
Okay.
And this is experiment 3.
So the voltage is changing or not? Yeah, it is changing, right?
Yes, sir.
Okay. Yeah. So just note down the voltage from where you are observing that those change in current and that voltage. Okay. And prepare
Yes,
that
sir.
table.
And this is experiment 4. And when I close this one, it will be full wave rectifier.
Okay. Okay.
Yes, sir. Okay.
Okay. So Rishika, now you can share the screen.
Yes, sir. Yes, sir. So can you see it?
Yes, yes.
Yes, yes, we can see it.
Yeah, sir. So this is for the first one.
So you have added one trigger.
Yes, this one. Is it okay, sir?
Yes, next.
Yeah, 1 second. So this is for A and B. Sir,
Yes.
Yes, yes.
Can you show us
Next.
the output? Yes. Yeah.
sir, this is for AMC. Sir,
Yes, yes.
राजेंद्र से भी नहीं है, कहीं गए हैं, फोन करके बोले वो पीएचडी का कुछ साइन करवाना है
अच्छा।
तो
सर ये मेरा बढ़ नहीं रहा था सर 12 पे एक्चुअली. Okay.
Yeah. So, Risika, you were saying something. What
Yeah,
is
1
it?
second. So wait. Oh. Sir,
Yes, yes. So the voltage is as you are increasing the voltage, so you can also observe the change in the voltage in that shunt circuit, right? Yes, it is showing
yes,
as 10.162. As you will go on increasing, it will also increase. Okay, and what
yes,
about 4, experiment
yes,
4?
sir, sir, yes, yeah, I'll show you. ऐसे क्यों आ रहा है सर?
So you have added the multimeter
Yeah, sir, I did everything.
positive.
It was working for me few minutes back. I don't know what happened.
No, that oscilloscope positive terminal, you
Yes,
have
sir.
to add it with that negative one, right? The negative one of that
Negative one.
multimeter.
But then, sir, it's not
Yes.
coming, I guess. Oh, wait.
But just now your friend showed that, right?
Okay, okay, sir, I'll do it.
Yeah. Yeah. Add it there. Delete that and yeah.
Here.
Yes.
Okay, sir, then.
And also check if you have that multimeter, is that voltmeter or ammeter? Which one you have selected? Double
That
click
I
on that
selected.
multimeter.
Yeah, ammeter only have.
Double click on it.
Yeah.
So yeah. So it is ammeter, right? Okay.
Yes.
Okay. Now you run it. You should get the result.
Yes, sir.
Yes. Now you can change the scale in that
This one.
voltage division. No, what is it?
Sir, you even showed 10:1:1 ratio, I guess.
Okay, that part, yeah, that part you can check. So
Do you want me to show it?
what? Yes, you can make it as 1 1. Okay. Make it as 1 and 1. Stop the simulation, then only you can change. Is it okay?
Yeah, yes.
Yes.
Yeah, it's 1:1.
Okay. Now you run it, and yeah, and now you change the scale in that voltage
Yeah. Yeah, sir.
window.
So 20 would be fine?
You change it, then you can observe that whether you can see it or not.
It's okay, sir.
Yes.
Yeah? Okay, sir.
Yes. And also you can also add that terminal B of that oscilloscope with that input. So you can plot both the input and output in a single window. Okay. So that
Okay.
the positive terminal of V, that will be added before D1, that is the diode, and the negative terminal will be added with before D1.
So where B positive to
Before D1. Before
D1. You mean
before
here?
D1. Okay. Yes, exactly. From there you can connect to the positive terminal, and the negative terminal will be added with the ground. Okay, then you
Is this okay,
run
sir?
it. Yes, and the negative will be with the ground. Okay, then after running it, you can observe both input and output in a single window.
Okay.
Okay, very good.
Sir, can I
So,
go ahead share
yes.
my
Sir,
screen?
is this
Sir, can I
Yes,
share?
yes.
Sir, Anish.
Can I
Yeah,
share?
Risika, so you
Yes.
can do it and take the screenshot and generate your that lab journal. Okay.
Sir,
So
can I
Hers,
share?
right?
all right?
Sir, can I share now?
I am sharing.
Okay, one by one. Who is going to share?
Arnav Jain.
So next I will share.
Yeah, Hers.
Yes.
We can see the screen of Hers. Now Arnav. Okay. Just one by one. Okay. Otherwise means none of you will be able to share your screen. So Arnav Jain, right? Okay. Hers. After this, you will share your screen.
Okay, sir.
Okay.
Okay, sir.
Wait a second. Sir, this is 1A.
Arnav.
Is it okay?
Yes. Yes.
This is 1B. Okay.
Okay.
And this is 1C.
Okay.
And I'd already showed you experiment 2 in the last class.
Okay. And how about 3 and 4?
This is 3. Okay.
Okay.
And this is 4.
Very good.
Okay.
Okay.
Thank you. Please note my name, sir.
Sure.
Thank you.
So
Sir,
yes.
I didn't show you the forward and reverse bias thing, sir. The second experiment.
The one you showed or you did not show? You did not show, right? Okay.
No,
Okay.
sir, I didn't.
So okay, you can show it.
Okay, sir. Can you see, sir?
Yes.
Sir,
Yes, we can see it.
is this okay, sir?
Yes, it is okay. So just note down those readings. Means when you are changing the input voltage, then the corresponding current and the voltage,
Yes, sir, I've
whatever
done it.
you are
I
getting,
posted on
note
the
down.
graph for
Okay.
both.
Very
Yeah.
good. Very good. Okay.
So now I am sharing.
Who is? Yes.
Sir, Anish.
So Anis, yes, Anis.
Sir, can I go after this?
Sir,
First,
So can I share?
Sir, I also want to share.
sir, do you want me to? Sir,
yeah, Risika, it's
do you want me to show the reverse bias also, or it's fine?
So
fine.
this is
Means
the first experiment.
I have understood that. Anis, right?
Yes, sir. First one.
Okay.
So then this is for the Lissajous pattern.
Okay, that frequency was very less.
Yes,
Yeah.
sir.
Sir,
So
can I?
and then further changing the ratio, we get different patterns. And then I'm going to the third one. Again, there's problem in frequency, I guess.
Yeah, so now actually you know that how to change the frequency and the voltage division scale, time division scale. These things you already know, right?
So this is the forward bias one. Reverse bias.
This is,
Reverse
yes,
bias.
this is reverse bias.
So I'm then varying the voltage. And this is the forward bias one.
Okay.
So now I'm sharing the third one.
Okay.
Sir, can I present next?
So, and this is the fourth one.
Ayush.
Yes, sir.
Okay.
Ayush, sir, can I go?
Again,
Okay. After Ayush, you can present. Yes. Anish.
so
So
this is the fourth one.
okay. So you can actually reduce that voltage scale. Okay. Not reduce. I guess you have to increase it.
So this one.
No, in that voltage scale, in that oscillator, in the oscilloscope. Yeah. Double click on that. So as you can see that that your plot is not coming in that window. Okay. So that is why you can increase that voltage scale. In that channel A, below that channel A, there is a scale, right?
Yes, sir.
No, that is the time scale. Beside that there is a voltage scale. That 5 volt
So
per
this
division.
one.
Exactly. You can increase that. Maybe then, yes. Now it is coming, right? Okay. Okay. And also you have done this for that full wave rectifier. Yes, you have to close that switch, that key. Then you can get that full wave rectifier. That key, this key also, that S1, below there.
Yes, just a minute. So for the full wave, it is not coming properly.
Okay, so you can open this
Sir,
key, this S2. This S2 you can open.
Okay,
That
sir.
S2, yes, open that, and now you run.
So again, this is
You have
half
to run
wave.
it. No, this is coming, right?
Okay.
This is full wave. Okay. And if you close that S2, then it will act as C-type filter. Then what ma'am was explaining, that you will get that DC output.
Excuse me, sir.
Yes.
Sir.
Yes.
So
Sir,
now can I stop sharing the screen?
Yes, you can stop it. You can
Thank
stop
you,
it.
sir.
And
Please note my name, Anish Kumar Singh.
Sure.
Sir, once got offline.
Ayush, right?
No, sir. Someone else share, sir. Sir, me just sharing,
Okay,
sir.
Hertz.
Sir, can I speak?
Yes.
Excuse me, sir.
Can I have done everything? So can I leave the meeting? I need to go get my vaccine, sir. Second dose.
Yeah, sure.
Can I leave the meeting, sir?
Okay, just a second.
Keep the
We can
attendance.
take. Yeah, sure. We will keep it in mind. Okay.
Sir.
Sir, is screen
Can I also leave?
Sir, Nilay, once
can
got offline, sir.
One by one.
Sir,
Can I
Nilay,
also
once
leave?
got offline.
Who? Niloy.
Yes, sir.
Yeah, Niloy. What is
It
the
is showing
problem?
offline. So it is showing offline once again.
1 second it is showing. Okay, so please try it after some time. What is the problem? Is there any problem of internet connection from your end? What is it?
Yes, sir. I'm
Okay.
having some internet issues.
Okay, then please try after some time again.
So it
Okay,
is
Niloy.
written that please wait for the remote side to accept your session request.
Okay.
So you have taken the attendance. Can I leave now?
Yes, you can leave.
Okay, sir. Thank you.
Can I also leave?
Sir, I am.
Yeah, Hers.
Share.
Yes, sir.
Can I also leave? Me, Rishabh Raj.
So this is first
Who?
experiment.
Sir, Rishabh Raj, 10087.
Okay, Rishabh. Yes, you can leave.
Sir, can I say
Thank
next?
Yeah, Hers.
Yes, sir. This is first experiment.
Okay.
Yes.
Sir, Ayush Kashyap, sir, sir, can I go next?
And this is 1B.
Yes, yes, yes. Ayush. After this,
Sir,
you will
after Ayush,
present.
can I go Narayan?
Sir, after you should,
Okay.
can I?
After Narayan, Gautam
So this
Kumar.
is 1B.
Yeah,
After
Hers.
Gautam,
Yeah.
Kshitij Singh. Sir.
This is a 1C.
Okay.
This is forward bias.
Sir, the ones who have presented, can they leave now?
Actually, you can wait for some more time because the lab is up to 11:40. As your friend, they had some important work. That's why I
Okay,
gave
sir.
them permission to leave. Okay.
This one is a forward bias.
Okay.
And this one for reverse, sir. This one is a third experiment.
Okay.
And this one is fourth one.
Okay. So you can change the position of this channel B or channel A. Okay. So below there, you can see that Y position and Y position.
Yes.
Below it, yes, yes, there. You can change it. So yeah, it will not overlap with each other. Yeah, you can do it. Okay. And also for that full wave rectifier, could you do that?
Yes, sir.
Very good. Okay. Okay, Hers.
Okay, so should I stop?
So now can I share?
Yes, yes. Stop
Sir,
it.
can I share now, sir?
Ayush. Yes,
Sir,
yes.
can I
Ayush.
share?
Yes, Ayush. Go on.
Yes.
Did
Sir,
Ayush
is my screen
can?
visible, sir?
Sir, after Ayush, I asked Sir Narayan.
Sir, is my screen visible, sir?
Yes, yes, it is visible.
Sir, this is for the second experiment forward by, sir.
Okay.
Change the value, sir. It will change. Sir, this is for the reverse bias, sir.
Okay.
And sir, this is for the third experiment, sir. Sir, the fourth one, sir, I am still doing, sir. I will present it, sir, later.
Okay.
Thank you, sir.
So
Sir,
1, 2,
my
and 3, right?
yes. Sir, my roll number is sir 10066.
10066. Okay.
Yes,
Sir,
sir.
can I go next?
Niranjan,
Can
sir.
I
Sir,
go
can I
now?
share?
Sir, I've been asking for
Sir,
so
I'm
long.
sharing.
So
So
can I
Vishal.
share?
Narayan, right? Narayan, you wanted to
Sir,
share,
my
right?
screen isn't been sharing. Like,
Sir, I'm
it is
presenting
not.
Sir Vishali.
Okay, okay, Narayan, just wait for some time. Let Baisali present first, then you can
Yes.
go on. Okay.
I'll go.
Thank you, sir.
Sir, have you noted, sir, my roll number, sir? Are you
After
sure?
Narayan, sir,
Yes, yes, yes. I
Gautam
have
sir.
noted it. Okay.
So this is
Sir,
experiment 1A.
1, 2, and 3, sir. I will show you the fourth one, sir. I am still doing it.
Yes, yes, yes.
Thank you, sir.
I have noted that.
Yes, sir.
Okay.
Thank you, sir.
Yeah, Baisali.
So this is 1A.
Okay.
So then this is 1B. So just a second. Yeah,
Okay. Why this Lisa just plot? Okay. Yeah, yeah, yeah. Now it is okay.
yeah. Then this is 1C.
Okay.
Then so this is the forward bias setup.
Mm-hmm.
So do I need to change the voltage and show?
Yeah. So you have observed means when you are changing the voltage, you could observe that changes in that both
Yes,
ammeter and
yes,
voltmeter.
yes,
Okay.
sir. So then this is the
Okay.
reverse bias one.
Okay.
And then so this is experiment 3.
Okay.
So here also I need to change the voltage and show. Like
I think for 15. Yes. 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 We can observe it. Yes.
okay. And so this is experiment 4.
Okay.
So this the second. So
Okay. So like your other friend, you can also means show that input voltage also in this same plot. Okay. So you can add that terminal B of that oscilloscope with that input. Okay.
okay,
Like your
okay,
other friend did.
okay, sir.
And what about that full wave rectifier?
So full wave rectifier. So can you?
Yes, you have to just close that switch.
So just a second. So which one? So this one.
Yeah, this one was for your half wave rectifier. And what about the full wave rectifier?
So just a second. My screen is again and again. Yes, sir. And so I've closed which one after
Exactly. Yes, yes. Now you can see what you are getting from that oscilloscope.
that? Okay. Not getting the pattern.
Sir, it'll come when it's kept on none, sir, from single.
Achha. Yes, sir.
Yes. Okay.
Okay.
Okay,
Thank you.
Boysali. Okay.
So,
So
I'm
Narayan.
Narayan. I'll go next.
Can I
Yes,
go
Yes, sir.
Narayan.
now, sir?
Yes.
So is my screen
Let
visible?
Narayan finish.
After Narayan, Gautam.
Yes,
Sir,
yes,
after
Narayan.
him, sir.
We can see it. We
So
can see
I've
it,
already
Narayan.
shown 1, 2, and 3, sir. So I'll just show fourth. So this is half wave rectifier, and when the key is closed, it becomes full wave. So and so now the input and output.
Yeah.
Okay.
So this is what I was mentioning. So all of you can do in the same way. And Narayan, you can actually shift the those scales such that it does not overlap
Yes,
with
sir.
each other. Okay. That position, that Y position you can change. Below that.
Y positions. Okay.
Below that. Yes, yes. That Y position you can change and
Yes, sir.
yes. So just make sure that it does not overlap with each other, so you can
Okay.
actually clearly understand. Okay.
Yes, sir.
And
Okay.
what about
Thank you,
3?
sir.
What about 3?
Sir, I've already shown 3 in the beginning.
Okay, you have shown. Okay.
Yes, sir.
Sir, this is Ankesh. Can
Okay.
I go next?
Sir,
Okay.
Gautam Kumar Jha.
Okay, so I've finished everything, sir. Thank you.
Okay. Okay.
Sir,
Okay,
can
Narayan.
I
Now you
ask
can stop.
So,
Yeah. Who is going to Milind?
Gautam Kumar
Yes,
Jha.
sir, I'm sure.
Okay, Gautam.
Sir,
After this, you can share your
question.
screen. Okay.
Sir,
Gautam.
after
Sir, this
Gautam
is the
Kshitij.
experiment one.
Excuse me, sir.
Yes.
Sir, sir, please accept my session request.
Your session request.
Yes, sir. Sir,
So
Nilan Ahmed.
you are still
Using
still it is showing you as offline.
Yes, sir.
Okay.
Sir,
I
this is
think
experiment one.
Raghavendra sir is not there. Okay, I'm checking it. Okay. Okay. Don't
Okay,
worry,
sir.
Nilay. Means if you cannot complete your experiment today, then you have
Yes,
time for next day also. Okay.
okay, sir.
Sir, hello, sir.
Yes, Milind.
This is experiment one. A. This is one B. This is one C. Ellipse.
Okay.
Sir, this is forward biasing. Is it okay, sir?
Yes, yes, it is okay.
Sir, this is reverse.
Okay.
This is experiment three.
Okay.
Sir, this is experiment four.
Okay.
Sir, please write my name.
Sir, can I
Yeah, Milind.
continue?
Yeah.
Sir, may
I
I
have. I
share?
have.
Sir,
May I say the Gautam?
Sir,
Yes, Gautam. So Gautam. So
Gautam
this will be
Kshitij.
the. This will be the. Okay. So actually, we have to stop because it's already 11:40. So maybe we can just go for another one or two screen sharing. And
Sir, can I
Nilay,
next?
Sir, after
sir,
Gautam,
Nilay,
can I go
can
as
I
well?
would
go
you?
next?
share next.
Sir,
Sir,
after Gautam, can I
sir,
go next?
Sir, after
Abhiraj
Gautam.
Rana.
It's
Don't
Tanesh.
worry. Don't worry. Means you have time actually. Don't worry. Means if you cannot show it today, then next day you can
Sir,
also
I
show
have
it.
done all the
Okay.
experiment but
Sir,
didn't show
ex-
any one.
sir,
Yeah.
experiment
Yeah. Don't
one.
worry. Don't worry.
Sir, one.
Yes, Gautam. Yes.
Sir, experiment one A, one B, one C, experiment three, sir,
Yes.
experiment four,
Okay. Okay. Okay, Gautam. So
Sir, can I please share my
Can I
screen
go
So
now?
can I
next?
Can
share?
I Wait. share?
next,
Can I share, sir?
So can I
Abhijit.
share?
So this is Abhiraj
one
Rana,
by
sir.
one.
sir,
One by
my
one.
name is
Okay.
Gautam Kumar Jha, roll number
Yes. Yes, Gautam.
101.
Yes. Yes, Gautam. I
Thank
have
you, sir.
noted. Okay. Ayush.
Yes, sir. Sir,
So
I had
Ayush,
already shown.
you already.
I
Yes.
had
Yes, you have
shown.
already shown. So
Sir,
this
only
is
no,
experiment
sir.
4.
Yes, sir. 3 and 4 were left.
Okay.
Sir, this is the third one.
So third one, you have added all this load, that 3.3,
Sir,
5.6,
I
12.
can remove just now. Wait a second.
Yeah, it's fine. Means you actually you understand that what
Yes,
exactly
sir.
we are doing. Okay. Okay, it's fine.
Sir,
Okay.
next. This is the wave rectifier
Okay.
with the input also.
Okay.
Is it okay?
Yes. Yes.
So
Okay,
can I
sir.
go next, sir?
So can I share?
Shomaditya, right? Yes, you can share. Yes. Yes, it is visible. Yeah, let him share his screen. Then you can do one by one. Otherwise, none of you will be able to share your screen. Okay, don't worry. Means if you cannot show it today, then in next class you will be able to show it. So Abhiraj, you
Yes, sir.
are presenting.
Yes, sir. Yes, sir. Sir, I
Okay.
have done all the experiments, sir. So
So Amaditya,
I
you
will
can
show
you
you
can you
fast.
can share your screen after Abhiraj. Okay. Okay.
Sir,
Yeah, Abhiraj,
Kshitij
go on.
after
After
Somaditya.
Somadip,
Sir,
can I
this
go?
is experiment number
Sir, after
1A.
Kshitij, Rishabh.
Sir, this
Rishabh, you have
is
already shown, right?
No, sir, I am different one.
Okay, you
Last
have
class I have
different.
shown for 1 and 2.
sir, this is experiment number 1C, and this is experiment number 2.
Your screen is not changing, Abhiraj.
So 1 second, sir. So
What is the problem? Is it internet connection?
sir, I think so.
So
Okay.
meanwhile, can I share?
Okay.
Can I go now?
Sir, I have done
Can
all
I
the
go, Pujol?
experiments.
Tanish.
Okay,
Sir, can I
Abhiraj,
share?
don't worry. Don't worry. You can show
Sir,
it
can
in
I
next
show
class.
in
Okay.
next
Can I
class,
show?
sir, please?
Yes, yes, sure. Somaditya, you want to share your screen? Okay.
So my roll number was 10059.
Yes. You just show it in next class. Okay.
Okay, sir.
Yes, your screen is visible.
Sir, hello, sir.
Okay. Why you have not done that forward bias? Okay, but you have to note down those readings, right? While okay.
Sir, I am showing next.
So can you? Okay. Okay.
Sir, I
Very
am
good.
showing next.
Okay. Okay, Somaditya. So you can stop sharing and let
Sir, I
Kitiz
am sharing next.
share his screen. Yes. So this is the last one. Okay.
Sir, after Kshitij, Rishabh Kumar.
Sir, it's the third one.
Sir, Tanish
And
Kumar Barnwal, sir. I've been saying for a longer time.
Actually, you have to stop at some time because the class is up to 11:40, and I guess you have class from 12, right?
Yes,
Sir,
sir,
can
I
we
was
share
waiting
the
Experiment,
next class?
patiently
sir,
for
I am
last.
sharing the screen.
सर
Yeah.
एक्सपेरिमेंट
Kitiz.
1 एंड 2 का सर जो 9 PM तक है ना सर डेडलाइन, तो आज कर सकते हैं 9 PM से पहले ना?
Yes. But
Thank you,
next
sir.
year that
The voltage.
next year you complete that before 9 p.m. because
ओके सर.
that we did that by mistake. But from next class onward, it will be before 9 a.m. Okay.
Okay, sir.
Okay.
I'm changing the voltage and the results are changing.
Okay.
And the last one.
So can I say I have been asking for like 15 years or something?
Sorry.
Can I say like I have been waiting for like my chance to just present?
Okay. Okay,
Sir,
Sasank,
this is the
you can
last one.
go after him. Okay,
Sir, this is the
actually,
last.
you can understand that the time is very limited, and in this time, actually, all of your friends they actually just try to share their screen.
Sir,
Okay,
this is the
so
last
just
one,
go
and
after him.
I've shown the results.
Okay.
My roll number is sir 10077.
Okay.
Kshitij Singh.
So Sasank, you want to share, right?
Sir, can I share my screen now?
So Rishabh.
Rishabh Kumar, yes, sir.
Okay.
Sir, I have shown 1 and 2 last class. I am showing 3 and 4 experiment.
Okay.
Sir, this is third experiment. I am changing voltage now.
So my screen is
This
sharing.
is third.
Yes, sir. This is third
Okay,
experiment.
we are seeing the screen of Sasank.
Yeah.
Oh, okay.
Okay, then let him finish. Then you can
Yes, sir.
continue. Okay.
This is
Okay, Sasank.
one of.
Tanish, I wanna go next too, sir.
Sir, you have written my